At t equals 0, an object is at a position of 4 meters of a 1D coordinate system and is moving in the positive direction at 2 meters per second. Its constant acceleration is given by minus 2 meters per second, and we are asked to find a function that represents the car's position as a function of time t. And there actually aren't any options here, so I'm just going to find a way to derive an equation for the car's position with when taking time as an input parameter. So basically we have a 1D coordinate system, which is simply a line. I'm trying to draw a line. So we have a line, and an object is somewhere along this line, and it is at a position of 4 meters away from the origin at when t is equal to 0 seconds. And basically it's moving in the direction of 2 meters per second, and it's moving in the positive direction. So that is basically its velocity of constant velocity of 2 meters per second. And it has an acceleration of minus 2 meters per second squared. So we just need to find the car's the function for the position when given these when given the values of these variables. So we're going to look to the kinematic equations to solve this. If you remember, there are 4 main kinematic equations. They are: the final velocity is equal to the initial velocity plus an acceleration times the time. The final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. The displacement is equal to the average of the final and initial velocities times the time. And the displacement is equal to the initial velocity times the time plus 1/2 times the acceleration times the time squared. So now we need to figure out which equation to use. If we look at the first one, this one only deals with velocity as a function of the initial velocity and the acceleration. We need to know those 2 variables. And but we are not looking for velocity. We are looking for the car's position, which is its displacement, or the change in its displacement, delta x. So this equation will not be used. Looking at the second equation, this is missing the time, and we need the car's position as a function of time, so we cannot use this one. If we look at the third equation, we need the average of the final and initial velocities times the time, but we don't know what the initial velocity is. We only know what its current velocity is at t equals 0. So that one isn't going to work. And if we look at the final one, this actually has all of the stuff that we need. We have a velocity and an acceleration, and it's the displacement is given as a function of time. Actually, one more thing, since this is at t equals 0, so the initial time, we would actually not have the final velocity, since this is when t equals 0, or the origin of time. So we can't use, we don't have a value for the final velocity. And the initial velocity is actually the one that's given to us, not the final velocity. So if you remember, the change in displacement, or delta x, is simply given by, or the displacement is given by the final position minus the initial position. And from this kinematic equation, that is equal to the initial velocity times the time plus half of the acceleration times the time squared. So now we just need to solve for the final position, which is simply its position at any given time interval, where you input the time as a parameter. So solving for the position, any position, that is equal to the initial x position plus the initial velocity times the time plus 1/2 times the acceleration times the time squared. And this gives us its x position as a function of time, where time is a parameter that you can input to change the value of the position. So now we just need to plug all of our known values in. So we know that its initial x position is given by 4 meters. That's the position here. It's given here in the problem, 4 meters. its initial velocity is 2 meters per second, and it's multiplied by time, and it's positive 2 meters per second, so it's moving in the positive direction, and it has a constant acceleration, that's 1/2 of minus 2 meters per second squared. So all we need to do now is simplify that. This becomes the position is given by 4 plus 2t minus t squared. And that is the car's position as a function of time t. And this is how you would solve this problem here.